we're at 1 inch equals 50 feet. So this is to scale. We should write that in here. 1 inch equals 50 feet. And we're going to put our north arrow in there, north, so we know which way we're supposed to be going. Okay, so that's drafting the description. So that's how you draft by hand. Okay, so we've drawn our description, and we talked about drafting a description at a 10-degree rotated angle. Now I've gone through and done a little bit of math, and I've already drawn a rotated angle. But for our rotation, we want to use this same description that we just drew, and I actually took the liberty of already drawing it. Same principle that we've done here, but I already drew it up. So let me pull that up. If I can find the paper. There it is. So I drew it up on a piece of graph paper. Okay. You can see, you know what, let me pull out this other one that I drew of our original description too. So you can see both the descriptions. This is the original one, just like the one we drew here. It's just in ink, so it's probably a little bit easier to show up on the camera. And this one is our rotated bearing. So we take our rotated bearing, and basically we did the same thing. We came here, but instead of going directly south, you can see that we went south. And there's our tick mark right there at 10 degrees. South, 10 degrees. Okay. Then we came over here. And instead of going 90 degrees, we went 80 degrees. Mathematically. Calculating that. And you can see my tick mark there. Went 80 degrees. Right there. So you can see that rotated the whole description that way. Okay, so so we have that, and I have two. I went ahead and I photocopied them on a transparency, so it makes it easier. So I'm going to show you how to rotate the bearings, and you can see that it's just a copy of what it is. See all of my oops. And my light is shining, but you can see all of my grid marks. Once we line them up, they're all there. So you can see the photocopies of the grid marks and everything as well. So we have that, and I'm going to show you how you rotate it. So this is going to act kind of like the Mylar, and I actually have an original one as well. Our original description. Well, let's just use our this one right here in ink so we can see it. So if we line it up right there, we can see the two different rotations. You see that? I'll tip it a little bit so there's not a glare. So we've got our two different rotations there. Our original, which is underneath, right here, and our rotated, which is on top. So mathematically, if we take them, and you can see that it's drawn at that angle, there. It's not straight. So if we take it, we can mathematically and adjust it, but we can also just rotate the bearing like that, and bam. So see this line right here that we want? This line should rotate with our section line. Okay? So our pencil drawing under there, can you see that pencil drawing? It's a little bit lighter. And we can rotate that. We rotate right at the axis right there of the section corner. So we keep that. And you see how we just rotate that? So that's where it was originally drafted. And we physically rotate it. And there it is. It matches up just perfect. So we don't need to mathematically do it. We can just draft it on a graph paper, and we can mylar, and stick it under the mylar, adjust it so our basis of bearing matches up with the section line, and then we know where we are. And then if our original drawing were underneath and our mylar were on top, then we just draw it. So no different than say here's our drafted version right here. If we drafted it on our paper there. Wow, where did it go? There it is. And this is our mylar with our original. Okay, so just the same thing, but we're gonna keep our original in the same place, and we're gonna rotate. Oops. Yeah. So we're gonna rotate our drawn to match our mylar section line. Same thing. So whether you're lining your paper up or your mylar, as long as they're lined up, then you can draw on your mylar and you can trace it, and you go, okay, that is where my section corner is, or my parcel is, based on the section corner. So rotating made simple without all the calculations. The other nice thing about it is by rotating it this way is that you don't have the liability for all of the math. So if you're not great at math and you could potentially make a math error, this kind of but you can still draft okay. This will take that out, because you can just physically rotate it and take out all of your math error. And you can see that if you've done it correctly, they should be the exact same. But much easier to draw it as the description originally is, so you don't have to worry about all that math. And much faster too, because the time it takes me to do all the math versus just rotating it, so much easier. Alright, so that's how you rotate a description manually. So much pretty similar to GIS and how you rotate them. We'll talk about that later in some of the other descriptions, or excuse me, some of the other chapters.